Yeah. So what I was trying to say is, whenever we talk about the BJT, it is something uh, like you are just putting, like it can be NPN also or PNP also, but mostly it will be dealing with the NPN junction only, NPN BJT. Okay. But see, the doping and the area of cross section of each of like the junction N or the P, or so all are different here. So in the diode when we were reading, so the doping, whatever we were doing, right, the impurity that we were mixing, okay, to make it as a semiconductor or work as a switch or a diode, right? So there it was totally different. Here will be the doping or the area of cross section. Let's for example in the BJT when we deal with the normal BJT, then so and in the BJT also it runs in different regions. Okay, there are some 3 4 regions. Let's one reason I'll just deal. Let's for example this was something like it is okay. So when we talk about the BJT that normally we work upon, right? So there the if you'll see the area of cross section for this P doped is smallest. Okay, and normally when we talk about a normal BJT, okay, let's for example if you are calling this as a collector, so there is a 3 junction that you already know. One is base and one is emitter. Okay, and the current, from where the current will come out. Normally, if you are talking about the NPN junction, from the collector it will come inside, right? IC, that will go out from emitter. Okay, collector, the name itself tells collect the current, and from the emitter it will come out. Even from the base, some current will go, but that will be very small. Okay, from the base also, normally in most of the problem that you will be dealing with in the BJT, the base current will always be zero or very small in the form of micro ampere or something like that. Okay, so normally this is shown as a 2 junction, like you can see there is a 1 and the 2 junction, right? So normally that's why you call it as a bipolar junction. So if you will try to show it, this is the collector, this is emitter, and this is base. So the current from the base is marginally, it's like almost zero. Okay, there's some current that will be coming from the collector, and so normally when you show a BJT, it is shown like that. If it's a NPN, NPN. Okay, this is how you show. This direction itself tells that a current is coming out from the emitter side. Okay, this is emitter. So normally IC and IE is same. Okay, because IB is 0. So if you'll just so, and everywhere you can use your KCL, KBL, whatever you were dealing with from the starting. Okay, so let's say example, this is a collector, this is the emitter, and this is the base, right? So the equation is something like IC is coming, right? IC and IB is going out, right? So your equation you can just write it as IC is coming, right? Similarly, IB is also coming. That should equals to IE. That's the one current that is going out. One is this is coming in. This is also coming in, right? And if this is almost zero, then IC and IB normally is equal. Okay,
Yes,
is it
sir.
fine? Yeah. And one more thing, see, uh, you have, I told you, right, this is NPN, right? So there will be some potential difference between this two. Like this is base, right? This is base, and this is your emitter, right? So there will be some potential difference. This VB, if you have to move, whenever you will be using the KVL, right? You will be, let's say here, it will be a potential drop of V of BE. Okay, and this is in reverse bias. So what happens in BJT? This is one junction, right? This is one junction. This is the other junction, right? If you'll just treat it like a two diode, right? This can be in reverse bias and forward bias, and this also can be in reverse bias and forward bias, right? So there can be four combination, right? So the combination that we are dealing with, okay, is normally this first junction, the collector base junction is reverse bias, and the base emitter junction is forward bias. Okay, so there can be other combination also. So that is what professor was saying. Whenever we deal with uh, the junction, the collector base is reverse bias and the base emitter is forward bias, what do you call this reason? The operating reason is like what do you call the reason?
Active region.
Active reason, correct? Yeah, see the combination, let's say example, this is the input one junction, base emitter junction, right? And then the other one is the collector base region. This can be forward bias and this is reverse bias. This is active region. This can be forward bias. This also can be forward bias. If both of them are forward bias, this generally call it as a saturation region that we don't have to read now. And there is a cutoff region also. Okay, when I guess both of them are in reverse bias, then this is a cutoff region. Or the opposite of this, the active region is called as inactive region. Okay, see this is the region where we have to read the active region. Okay, in this region only the normal BJT will start working as a amplifier. So BJT works as a amplifier here. Okay, that will do the amplification of the current, sorry, the potential that you are giving. Okay, you would have heard about some of the term also of current gain or something, right? So here I already, so normally this is your VJT, this E, the collector and the base. IB, this is IC, this is IE. I told you IE is equals to IB plus IC. Okay. There's one term beta. Okay. Beta is normally IC upon IB. And I already told you IC equals to, then it will be beta times IB. This value will be very high. Okay, because I told you IB normally is very small, and to have some significant value for IC, beta must be a very high value, right? This you call it as a current gain, okay, for a BZT. So beta, you must be remembering, beta is equals to what? IC upon IB. And this, in the most of the problem that you will be dealing with, most of the BZT that you will be dealing with, it will just be given that beta is very high or maybe infinite. Okay, normally it will come when you ever you will be calculating, it will be coming out to be in the form of 150, 200, something like that, 500 and all. So it will be, beta will be very high. Normally there is a term alpha also. So what is the value of alpha? What is alpha? So input current upon output current. Okay, If you'll write the alpha in term of beta, so see here I told you, right? Normally the equation is what? I equals to IC plus IB. If IB is very small, right, then IE and IC will be comparable. That means what? Alpha will be very small. Okay, if you want to write the alpha in term of beta or beta in term of alpha, you generally write as 1 of 1 minus alpha. So alpha if is very small, okay, let's take it 0.01. So if you'll take it 0.01, you'll get the value of beta. So this alpha is very small, beta will be very high. This is how. So this is the normal whatever terms that is related to the BJT. So you have already known the current, the base current, collector current, emitter current. One more thing, I told you, right? This potential, if you have to move from here to here, there is a potential difference of VBE. Okay, it's a junction, right? Similarly, here you have a potential difference of VCB. Okay, you can just think of as this BJT as here VCB, and here you can just think of as VB. Normally, VE for a silicon diode, like silicon type of doped material, you call it, the value is 0.7, and for the germanium it will be given 0.5 or 0.7, whatever the value. So this is IB, IC, and IE. Okay, and this will be what? This will be voltage VCE. Okay, is it clear to everyone? See, even though you can use this, if you want to apply KBL here in the whole circuit. Let's, for example, I want to apply. What will be the value? If I'll start it from here, so this will be what? Plus V CB plus V BE, and then again you have what? VCE, right? Minus VCE equals to 0. So if you just want to write it as VC, both are same. This is VCB is what? VC minus VB plus VB minus VE minus VC plus VE. Okay, this will get cancelled, this will get cancelled, this will get cancelled. Okay, so simply you can use anything here, like KVL KCL that you have read, that also you can use it here. Okay, you can see that this is following. If you, the potential difference between the base and the collector, then the base and the emitter, and the collector and the emitter, if you're just adding, you're getting 0. Okay, is this clear to everyone or not?
Yes, sir.
Okay.
Yes, sir.
So
Yes,
I
clear.
hope all the term we have discussed, right? So any confusion in this? No, right? In the term at least, the what is collector current, emitter current, base current, and the potential across any of the diode, any of the junction. See here also in the BJT normally it can be DC analysis and AC analysis both. Now we are just doing DC analysis just to give you some space, right? We'll do the AC analysis also. AC also we have to read. Okay, so AC analysis means you are just giving AC in as a input. Okay, and DC is like you are just giving DC. I hope this making sense. So maybe we'll try to solve a problem that will help you. Yeah. See, you have a BZT been given. Okay, so it has been given that this is the question. You have to calculate the collector voltage. So collector voltage will be, this is collector, right? So this is VC, and other information are, so beta is very high. Okay, let's give beta is equals to some 50, and the VBE. So this is what? This is collector. This is base. This is emitter. The voltage VBE is already given as 0.7 volt. You have to calculate IB and VC. See, IB is very small, but not like, for many of the problem it will be 0. Okay, and for many problem it will be very small, maybe in the microampere or something like that. Okay, so here you have to calculate the IB current and the VC, the voltage here. Okay, how will we start? How can we start?
So assuming the BE terminal is in forward bias, we can find the current.
No, see here. First of all, whenever you are dealing with the BZT, okay, uh, if it has been given, so this is already reverse bias and this is forward bias, so you don't have to treat it as a diode. Okay, so you can use KVL, right? You can go from one point, like from starting to like in a like whole circuit, okay, and then you can use KVL equation and all. So let's say example, let's think this is some current. Okay, this, let's say example, this is IC current, this is IB current, okay, and this is IE current. Okay, so now if I have to go, let's for example, this is some voltage, right? So this, from this ground to this ground I can move, right? I can take this direction. Okay, so if I have to move from here 20 volt till this ground, how can I write the equation, the KVL equation? Minus 20, then there is a potential drop of what, how much? So this is, sorry, potential drop of plus IB times 430, right? So we have started from here 20 volt. So if you have been given an equation something like that, how will you write? So they, let's say example, this is how it is given. So this is grounded 20 volt, then there is a current of IB is moving with 430 kilo ohm, then you have what, VBE, then you have a resistance of 1 kilo ohm, and then a ground. Okay, and here the current is IE. How will you write the equation? You can write the KVL equation here, right?
Yes, sir.
Can you write? Yeah. So how will you write? You will start with minus 20, then plus
Plus
minus, right? So
430 into
drop
IB.
of 430, correct? And then again a potential drop VBE, then again plus 1 times IE equals to 0, correct?
Yes, sir.
Yeah. So the same thing we have done it here also. So you can start it from here. Okay, you can go like this, because this is a ground. We have started from ground and we are moving to ground. Okay, you can write it like that, even though you can write it like this also, but the problem here is VCE, I don't know, right? The potential drop of VCE we don't know. To get VCE, if you have VCB also, we can get the value of VCE, I told you, right? But we don't have the value of VCE itself. If you don't have the value of VCE, I can move it like that, from this ground to this ground. So I choose this direction because VBE was given as 0.7. Correct? Clear? See, yeah. Okay. So now I've written the equation. So this is equals to 20 equals to what? IB times 430 plus 0.7 plus IE. What can I write IE? I in term of IC and IB. You can write it as IB plus IC. I emitter current is same, right? Emitter current is what? Emitter current is the base current plus the collector current, right? So one current is coming IB, IC is coming here, IB is coming. So the whole current IC plus IB will come out like this, right? Correct?
Yes, sir.
So yeah. So IB and IC, can I write IC as beta times IB? You already know that beta is what? The current gain is IC upon IB. So IC is equals to what? Beta times IB, right? So I can write it IE is equals to 1 plus beta times IB. It's not it. Is this clear?
Sir,
Yes,
isn't
sir.
it breaking the KCL?
How?
Because in the, can you just scroll down?
Hmm.
Here from 20 volt IB is coming out, and in the same stretch, that is in the same branch, we have also IE.
So
Nothing, sir, nothing.
okay, you are thinking that how can this both, but just this I've just written to make you understand. It's not uh, like that, right? You are moving from here till here, right? The current here, i.e., one current is coming out from somewhere else also, right? I see. But what I am trying to say is you can use the
Yes,
KVL,
sir,
right? You
yes,
can
sir.
move from one
It
ground
is,
to
that
yeah.
is what I am telling.
So you can use it, right? The from one ground to the other ground you are
Yes, yes,
moving,
yes,
right?
understood, sir, understood.
Okay, okay. So now you can write IC equals to beta times IB, right? So here you can write it the same, beta times IB. Sorry, 1 plus beta times IB, right? 1 plus beta. So what was the value of beta? Was 50, right? So that will be 51 times 51 times IB. Correct? So now you have 430 here and 5 here. So you'll be left with 19.3 upon 400. How much? 51. 481 IB equals to 481 IB. So IB will be 19.3 upon 481. What will be the unit of this? The current? Unit of current will be ampere, but like it will be microampere or milliampere, which one?
Microampere.
Yeah, correct. There will be microampere. Because I already told you in the previous session also, normally when you deal in the BJT or the diode and all, the resistance will be in kilo ohm, voltage will be normal volt only, and the current ampere will be mostly in milliampere. But here you can see that as you're getting everything in the milliampere, so you don't try to be write it everywhere 10 to the power minus 3 or 10 to the power 3. Here whatever the value you're getting is very small. I told you, right? The base current that you will be getting mostly in the form of microampere, microampere itself. And here also if you will divide, you will get something like 0 point some value milliampere. And if you will convert it, let's say example, what is the value that we'll be getting? Can somebody divide it? 19.3 upon 481. Will be some how much? 19.3. Okay, let me do it.
0.040.
0.047. So 0.047. So this was in milliampere, okay. But if you'll just write it as, then it will be 47 microampere simply. Okay. So whenever you are dealing the analog, okay, so like in the BZT at least, whenever or the diode that you are solving, always do not write everywhere like the micro or milli. So and then in the end you will be getting the ampere if the resistance that you are dealing. So most of the resistance you can see that it is in the form of kilo ohm, right? Kilo ohm, kilo ohm, kilo ohm. Okay, and the voltage is in the form of voltage, volt directly. No, like nothing micro or any kilovolt or something like that. Okay, so your current simply will be coming out in the form of a milliampere itself, right? So V equals to IR, right? So if this is in kilo ohm and this is micro ohm, like micro ampere, so your voltage will be in the normal volt itself. So you don't have to write it everywhere. You just do the calculation. In the end, you will be getting in the form of microampere itself. Milliampere itself. For this case, it was microampere because the beta will be very small. The current the base current normally is coming out to be very small. Okay. So now you have to calculate the VC. How will you calculate VC? What is the value of VC here?
Sir, we can calculate the value of IC using IB. IC is equal to IC plus IB equal to IE,
Yeah.
and then
Yeah.
we
From there
can
you can.
do VB. Sorry, V 20 volts minus VC equal to IC into R.
Correct. So you can start it from here and go here, right? So if you start minus or directly 20 equals to 2 times IC plus VC. Correct? So if anybody didn't got it, you can just think of as this is 20 volt, then you have a resistance 2 times IC, then you have a potential VC. Correct? You will start it from here minus 20 plus 2 times IC plus VC equals to 0. So 2 times IC plus VC
Sir,
equals to 20. Yeah,
sir,
yeah.
why do you think it separately? Two separate circuit, please. I can't understand that.
Which two separate circuits?
Separate path. IB and
Okay.
IC, two separate equations, separate path.
Okay, so this, okay, there can be in a same circuit you can have a like normally you can have a 2 3 like loop, right? Where let's say example for this loop, we started from a ground and we moved to the ground, right? So this is the correct equation, correct. Like you can use the KBL. Here also you have started from ground,
Okay.
and then you can go till ground, right? So here also there is a ground, right? So this is something like that. This is VC. So this is also we are starting from a ground, we are moving and then a ground. So if 20 volt was there, the whole 20 volt should drop it here, or remaining should be here. Correct? Because it's a ground, so ground to ground, if you can use the KVL, right? And that should follow the KVL rule. So that's why you have started from here, and even though you can use this path also, but this path we
Sir,
are
is
not using
ground to
because
ground
VC we
required
don't know.
only if the voltage is known? KVL is always valid for any loop.
Yeah, KVL will always be possible for any loop here. See, this also it will possible, but we don't know VCE. That's why I'm not using this path. I can use for this path because I know if I know, see, if there is a 20 volt potential here, so there will be some drop and the remaining will be here, right? Okay, and whatever the voltage there, that should drop here. So VCE and then the drop should be here. Even you can calculate the VC is also here because now you know VC. VC you know. Whatever drop here, the remaining drop you already know. The current IE you know. So the drop here you know already. So whatever the remaining drop is there, VC will be that value. Is it clear to everyone?
No, sir,
Is
I
it
didn't.
clear or okay? So
Sir,
what I'm
I'm
trying
not
to
sure
say
how
is
VC is grounded. It is
no
how VC is
VC.
grounded.
No, let's say example. See here what has been given. See Okay. So if you have to, VC is this one, right? You can't write it like this. This is VC only, right?
Correct. So
No?
there is not actually grounded. It is just we are calculating that the in the path just we are calculating the what is VC. But how we are saying it is grounded. That's, I'm not sure.
What grounded?
How are we saying that it is VC is grounded there? It is continuous path from the 20 volt to emitter direction, right? And emitter in that is grounded. But how VC is grounded there?
This, no, it's not grounded. I'm just saying that
Okay.
how will you write the equation to make you understand? I'm just converting it as a grounded. So to ground
Okay,
you can
assuming
use.
that there is it is ending and there is grounded. Okay.
I'm just telling you, you can use the your like whatever the voltage. So any voltage you have, right? Let's for example any circuit that you have, right? You have 20 volt here. You were having 20 volt here, correct? This is grounded. Okay. So you have some current in between. Let's for example you have to find the voltage here. Okay, so 20 volt, then there will be a drop of something, right? Some because the current is already passing here. So IC is already there and resistance you know. So whatever the from the 20 volt there will be some drop, right? And the remaining voltage will be here. Let's for example this is V. Okay, if I have to write in the form of equation, I can write it like this, right? This is the
Right.
voltage here, remaining voltage. So to write, just to make you understand, minus 20 volt, and then there is some drop, IC times RC, okay, plus V equals to 0.
Right.
Okay, to
Got
get
it.
the value of V, you can write it like this, right? V equals to something 20 minus IC into RC. So what is this V? The voltage that is left here is what 20 minus the drop IC times RC. Okay, so even though you can directly write it as the voltage here will be what, the voltage here VC will be equals to the whatever the value 20 volt minus the drop IC times the RC value 2 kc kilo ohm. This will be the value. Okay, is it clear to everyone? See,
Yes,
to
sir.
know the potential here we see there's no need to use the KVL also. I just made it to make you understand. If somebody is not able to understand, you can just put it like this, the VC here, and then move it from ground to ground, so that it will be clear for you to you can use the KVL. Okay, if you are making it as a ground, like VC, you can just think of as this is a potential VC, and then the other part will be grounded, right? So you can move it from ground to ground. If you are clear with that, like if you are able to understand it without this also, you can. So this is a 20 volt, okay, and there will be a potential drop of something. So remaining voltage will be here. Okay, now if I have to list, for example, if you have understood it, can somebody write this equation from this ground till here? Because you can use it. This from this ground, I am moving. So there is a 20 volt, some potential drop here, some potential drop here, and then potential drop here. Correct? So how can you write this equation? This will be what? Minus 20 volt, then a drop of
2 into IC
IC. Correct.
plus
Then this is what?
then
V
VCE
C E plus VCE, and then there is a drop of
1 kilo ohm plus into
yeah, this equation.
I.
Okay, is it clear to everyone? This question is clear to everyone or not?
Yes,
Yes,
sir.
sir.
Okay. So
Sir, just a doubt. Can we use a
yeah,
voltage divider there? Like to find the IB? Can you
where?
please show this circuit?
Yeah, voltage divider also you can use it.
Okay, yeah.
But how will you use it here?
We can find the VB
Voltage
here
divider,
by
any rule that you have used it in the electric circuit, you can use everything here. But how will you use the divider? That is what I'm thinking.
like if we can find the VB here, then I can find the IB also. Like the 20 volts is getting divided into both the both the resistor, so I can use the voltage divided.
Okay, you're saying that the 20 volt is getting divided between this resistance and this resistance, right?
Yes.
This is what you're saying?
Yes, sir.
Okay, you can, but there is a potential of VCE also, right? So that you have to reduce. So that reduce further. So because there is a VCE also, drop of VCE. If you are moving from this C, this is a junction, right? This is one collector junction. You are moving to collector to emitter, then there some drop of VCE. Okay, that you can't miss out. See, whenever I was writing an equation, let's for example, I'm moving from here to here also. So you have to take care of this VBE if you are moving from one junction to other, right? The base to emitter. So this VBE 0.7 it was given. So you know the value of this. Here VC I was not knowing, right? Correct?
Yes.
So you can divide it, but this should be there in your mind. VC also, right? So the whole voltage, so there is some drop already here. So if you know this drop, then you can, like, the remaining portion will be divided between this resistance and this resistance. Okay? And then also see why you can't use, see, here also the current is different here and the current is different here. Here you have just IC, here you have IC plus IB. So some current is coming from IB also. Okay?
Yes, sir. Understood.
Yeah. So here also, so voltage divider and all, when you can use it, right? So see, first of all, this VC is making the trouble, and again the current is also different in each of the resistance. So that will not be applicable, even though it can be applicable if, let's say example, here the resistance was there. Okay, so then you would have used it, but like for our question, the resistance is not here. Okay.
Yes. Thanks.
Yeah. So if, let's say example, you have a question something like, again you have a, mostly it will be NPN only. Okay. There's a collector, base, emitter. You have a resistance. You have a resistance here, RC, and this is connected to 15 volt. Beta is given. And you have given VC also. This is given as 9 volt. And this is grounded. Now you have to tell me the value of RB upon RC. There is some current IC. From here also some current IB is coming, and here it is going IE.
Sir, because VB is known, can we instead of the terminal, can we use a voltage source?
Where? Here.
No, VBE. VBE is 0.7, so we can replace that with 0.7 voltage source.
Yeah, you can replace it with, like, you can write it as something like that. You can write it at, let's say example, is starting from 15 volt. 15 volt. Then you have a resistance RC. Then you can have this RB. But the only difference is you should be taking care here. The current is IC. The current here is IB. And then you can replace it with, this is VBE. Okay, and this is grounded. Okay, so it can go like this. This is what you are asking, right?
Yes, sir.
Yeah, you can use it. So one path is this one.
But sir,
path is
one
here
thing,
only.
this RB and this RB is not connected with ground, right? So how can we say that IC and IB, how IB is coming out of IC?
IB is coming out of IC.
IC and so we also need another kind, like IE is also there. So if
No, I is equals to
IB plus
IB plus
IC,
IC. See this, what you are trying to say. See, okay. What you are trying to say is this should not be IC. This is what you are trying to say. You can take anything. Let's for example, you are taking some value. This is getting some value is coming here. IB, the remaining portion is coming here. So I minus IB here. This is equals to IC. You got it right. See, there is some current that is coming. Some current will go here. Okay, and the remaining current will be your collector current. Have you understood it?
yes sir, understood.
Yeah. So if I want to write first equation, what will be the first equation?
15 minus IRC and then
15
minus
equals to
IRB.
IRC plus IBRB plus 0.7. Correct? This will be
Yes
the
sir.
first equation. Yeah. The second equation, can I write it from here? Here till here only. What is this? The drop of 6, right? 6 is equals to what? I times RC. Correct? Is it clear to everyone?
Yes, sir.
Yeah. Okay. Now, okay. Can I write I is equals to what? I is equals to IB plus IC, right? This I is equals to IC. Some part is coming here as IC, some part is going here as IB. Correct? So this is what IB plus beta times IB. What is the value of beta? 75, right? So this will be what? 76 times IB. Is it clear to everyone? This I value is getting bifurcated as some base current and some collector current. This is what? IB plus IC. What is the formula for IC? IC is what? Beta times IB. So whole together I is equals to what? Beta plus 1 IB. Beta is 75, so 76 IB. Is it clear to everyone? Not clear? There.
Yes, sir.
Yes,
Okay.
sir.
So now in the first equation you replace I with 76 IB. So if you'll replace it, the first equation will be what? 15 equals to 76 IB plus IB times RB. What is the value of RB? Okay, RB, so we have to calculate, right? RB upon and 0.7. So we can move it here. So it will be left with 14.3. Correct? And here we will be having 6 equals to 76 IB. IB RC also, right? RC also. RC. How will you calculate the ratio? These are 14.3 is equals to what? If I'll take IB as a common,
We need the value of IB.
it will be 76 RC plus RB. Okay, I need something else, right, to calculate RB upon RC. Okay, how will you do that? RC upon RB upon RC, it's asking, right? Okay, I'll just divide it both what will I get? Okay, I'll just divide it both equation first and second. What will I get? 14 upon 0.3 upon 6 equals to IB times 76 RC plus RB upon 76 IB RC. So this IB will get cancelled. We will be left with what? 76 RC plus RB. 176 RC. Okay, let's divide everything with RC. If I'll divide everything with RC, yeah, then we can get, right. We need RB upon RC, right? So we'll divide everything with RC. So we'll be left with 76 plus RB by RC upon 76. Correct? Equals to 14.3 of 6. If we'll just multiply it here, we'll be left 14.3 76 76 equals to 76 plus RB by RC. So we'll be left with 14.3 upon 6. This 76 will come here. So minus 1 times 76 equals to RB by RC. Is it clear to everyone? Is this clear? How did we solve this?
Yes, sir.
Okay. Okay. Can you solve some more problem? Is it making like now at least the problem you can solve, right? So from the BJT, can you solve some more problem? Are you there? Do you want to solve some more problem?
Yes, sir.
Sir. Yes, sir.
Okay. So let's solve it. There is a two BJT, okay, connected. So there is some current I. The same current will be passing here I. Okay, so here the question is, the question is, so beta has been given as very high. So whenever you will be given beta as very high, you just have to think that the base current is 0. Okay, if the beta is given like beta is equals to 100 or something, you have to calculate the beta value, like the current across the base. But if it is been given already as very high, that means the beta current, like the base current, you have to take it as 0. Okay, so here also the current IB you have to take it as 0. Here also the base current, you have to take it as 0. The VBE for both the BJT has been given as 0.65 volt. You have to calculate the current across this 2 kilo. It is very simple. What will be the current?
There is a I for both the collector and emitter.
What? I for?
You have written I for 2 kilo ohms incoming and also for the emitter also.
Yeah, both will be same, right? This will be same because there is no base current, right? So if I is
That's
coming,
what I am
the
asking.
same
Is
I
that
will come
because
here,
of
right?
there?
Yeah, it's because there is no base current, so the same I will come here also, and the same I will come here also.
Okay.
Okay. The current that will be the collector current for the first BJT IC will be equals to IB because I is equals to what? IC plus IB, and this is 0, right? So the same collector current will be the emitter current for the first BJT, and the emitter current for the first is equals to the collector current for the second BJT, and similarly the emitter current for the second BJT will be equals to their collector current. So all will be same because there is no current coming from the base current. Okay, can you tell me what will be the value of this I, small I?
Yes, sir. The 6.5, 1.85, and 1.65 are in series.
Correct. So this you can just directly use it at KVL, the whole loop. So this will be what? 6 plus 1 plus 1, 8 plus 8.5, 8.5, and then 9.15, and then 8. So 10, right? So whole together 10. So you'll be having 1 milliampere. This is small I, correct?
Yes, sir.
See, 10 volt is here. Drop here, there is some drop here, then there is some drop here, then there is some drop here, and then it is going to the ground. So you can use the KVL. So if you just add it, all of them are in series itself. 6.5, add it 1.85 and 1. So current will be same. The current that is coming I here, because there is no current going here. There is no current that is divided here. So the same I will come here also. And again the IB is 0. So same I will come here also. And then it will go here. So it will be something like 10 volt equals to 6.5 times I plus 1.85 times I plus 1.65 times I. Okay, so that's 1 milliampere. Making sense to everyone? Now you have to tell me the value of this I.
So these 2 kilo ohm and 1 kilo ohm are in series.
2 kilo. No, but there will be some drop here, right? The voltage drop here, voltage drop here.
Yes, 0.7 volt.
0.7
You use it the loop
65.
in this here. Use loop here, no? Because VB you know, right? 0.65.
Yes.
Why can't you use it in here, this loop? See, if you use it in this loop, how will you write the equation? This is plus minus, right? So minus 1.65 times 1. Then there is a 0.65. And then what is this? Plus I equals to 0. So I is equals to what? 1.65 minus 0.65. So again 1 milliampere. Correct? So this I is also same as this I. So I is equals to 1
What
milliampere. So this small I is also 1 milliampere. Yeah.
IB is 0, right? In loop, why you're not accounting there?
Which IB?
IB through IB equal to 0, right? That bottom circuit.
IB is 0. Yeah. Base current is 0.
So how we are not accounting that in that KVL? Yeah.
Not recording in the KVL.
No. Yes. Why you're not adding the no resistance?
What I am not adding?
The IB equal to 0 is not accounted in that equation, KVL equation.
But IB is already 0, right? So why will we take care of this IB?
Oh.
If the current is 0, right? So the drop, it will not make any difference, right?
Voltage.
So, and we are using from here, right? So
Voltage
this
drop
is
0.
how we are using. And the second equation, what I have used it here. Here we can use the loop, right? Is it clear to everyone how this I came out to be 1 milliampere?
Yes, sir.
Yes, sir.
Clear to everyone? Okay. So, are you able to understand it or not?
If we consider the right side, that vertical circuit, the branch, can we use the same or not? What is the
What? I can't hear you. Can you just repeat
Sir,
it?
if we consider the right side branch completely from starting from 15 volt, 10 volt to the ground, right? So
From here?
yes,
No, we can't use it now. We don't know the
VC.
junction voltage, right?
VC. You
Yeah,
don't know.
VC we don't know.
Okay.
Yeah. That's why we are not using. VBE I know. That's why I used it here. VBE was given, right?
Yes.
Yeah.
Sir, please explain me again how you find the value of capital I.
Okay. Capital I. See, is this clear that this capital I that is coming out from here, all will be same. Is this clear? This capital I
Yes,
here
sir.
will be
Yes.
same as, because okay. Now uh, to calculate this I, okay, can I use the KVL here in
Yes.
this circuit? I can use it, right? So if I have to use the KVL here, what is been given here? So there was already a current here I, that was 1 milliampere. So I am using the KVL like this. If I am using like this, I'll start it from here, minus I times 1.65, and then I am moving here. Then I have to take into consider, like we have to consider this plus VB also, correct?
Yes, sir.
And then again there is a drop of I times 1 kilo ohm equals to 0, correct? I am moving in this loop, so this I can use it, this loop I can use, right?
Yes, sir.
Now I is what? 1
1 million.
milliampere. Okay, so 1 milliampere, I already told you, whenever you have milliampere, you don't take care of this milli, like, because it will be because you are multiplying with kilo ohm, so it will be taken care, so you don't have to worry. So this is 1.65, and this is what? B is what? Plus 65, 0.65. So minus 1.65 plus 0.65, this is minus 1, plus 1 equals to 0. So I is equals to 1, right?
Yes, sir.
Milliampere. Yeah, so this is how it has been calculated. Clear
Yes,
to
now
everyone?
got
Okay.
Sir,
Yeah.
sir, but IB is 0.
Yeah, IB is 0, right? It has been given already. The beta is
Yeah.
very high. If the beta is very high, then IB will always be 0. Okay.
So no current flow through IB. Then the
No
wire
current is
disconnect.
flowing. No current. Yeah. No
Then the
current is
wire
flowing from
disconnect.
IB. What?
Then it don't create any loop. The wire disconnect.
Okay.
IB is 0. Then no current flow through IB.
Yeah. There is no current. See, whenever you deal in a BJT, right? See, whenever you deal in BJT, okay, IB, you have to consider very small or 0, okay, but you can use this KVL equation here. You can't say it like this is a junction, right? It's not something like a wire or something, right? So you are taking
Okay,
care of
okay.
this potential, right? VB. Okay,
Okay,
so you
sir.
can use it. So yeah.
Okay, sir. Thanks.
Yeah. No problem. Okay, so do you want to solve some more problem, or we can just drop it off? what do you guys need? Because there's too much of EC for you, right? For the last 4 5 days. Next week also we'll be having some more session, because next week we'll be having, I guess you have the quiz paper, right? In the coming week.
Yes,
16th
sir.
you have the quiz, right?
Yes,
Yeah.
sir.
So next week we'll just be solving the problem that will help you in the quiz paper, okay? From this whole, from week 4 to week 5 to 8 itself. BJT, there are some more things like AC analysis I haven't done. Maybe in the Monday session we'll do the AC part, okay? And whatever remaining portions we'll be just solving it. If you want, we can solve some more problem if it is fine for you
Sir,
guys, because it's like already for the last 2 3 days I have like too much of this EC sessions and all.
sir, I had a doubt.
Yeah, yeah.
So in our exam, we will get this uh, diode and not diode, but this circuit will always be in forward bias, right?
Yeah, this always be the your
BJTs.
base emitter will be, yeah, yeah. You will working like active region only.
So it will always be in forward active region. So like if for in general, it can happen that the collector voltage, it can increase, like the voltages can be in a way that the BE terminal is in forward bias, but also the collector and base terminal is also in forward bias. This can happen, right?
This can also happen. I told you in the starting. Or
But
the
we
four
need not
combination can happen
consider
because
that
it's,
because it will not come in our exam, right?
no, yeah. So see, whatever we are dealing BJT as an amplification, like how can the BJT work as an amplifier or amplification, right? So in those cases, the B should be in forward bias, and the collector base region, the junction should be in the reverse bias. Okay. For the other reasons, there are other reasons also, because it's like a head and tail, right? This forward, the reverse. This also can be forward reverse. So two into two. So you'll be having four reasons for sure. So we are just dealing with this reason, where your BJT will work as an amplifier. So BJT can be used as some other things also, right? So the others, like if this is in forward bias will work as a saturation region. But we don't have to read it about these three.
Okay, sir.
Okay?
So like as like diode, we don't have to do any guessing game, right?
Yeah, yeah. You don't have to do any guessing. As of now, you don't have to do any guessings also. It is mostly in the active region only. Okay?
Okay, thank you, sir.
Okay.
Sir, week 7, last graded question. I think uh, not sure means
Yeah, week 7.
last graded question.
Week 7 last grade question.
Yes, 10th.
Okay, let me open it. Okay, so in the last problem, what is that given?
So in last question, I solved it, but
Can
I'm
you see my
getting wrong
screen?
answer. No, sir.
Okay. Let's try it out. So the problem here is you have a VGT been given. You have 9. You have 9, and then you have 2 kilo. 20
Sir,
volt
are
is
you
a
writing something?
yeah, yeah. It's not visible.
No,
Visible,
no, sir.
teacher.
It's visible.
What?
It's visible
You
too.
can't see it.
Yes. You can.
Oh, okay. Is it visible to everyone?
Yes, sir.
So,
Okay, this is grounded. Okay, what you have to calculate? VB has been given 0.7 volt. Beta has been given 100. What do you have to calculate? The collector current, IC. Okay. So this is IC. Let's, for example, you are taking this as IB. Correct? This is IB. There's some current that is coming here also. Let's, for example, this is not IB. Just take this as IB. Let's, for example, some current I is coming here. Here it will be, the remaining current will go here. I minus IB. Okay. So use it, if you'll come from here, you'll go like this. Or maybe you can do it like this also, no problem in that. Okay, so in which IC you are getting it wrong?
No, VC.
I see lower. Okay. It was
IC is correct, right?
yes.
Yes.
Then
So
IB.
what is the value of IC that you are getting? VC, you can correct it
2.03.
from here, 0.03.
Yes.
IC is 0.03.
2.03.
Okay,
2.03.
2. Okay, then what's the issue? IC you know already. Then you can write it like this, right? From here, you can get the
Yes,
minus
sir.
20
Everything normal, sir.
plus IC in my plus VC
Sir, I think
plus
there
2
was
times
VC also. I think 24.
what?
There was VC also, right? VCC.
24 years.
That is 24. Okay, that is
Yes, supply
24.
voltage.
Okay. Then also 24. Okay, 24 equals to 0. So IC is already
No,
you are
we don't
knowing.
have to find VC. We have to find VC.
No, it's given the value of VCE.
And last question.
Yeah, 10th one, right? VCE you have to calculate. This you have to
Yes,
calculate.
it is asked for this.
Ah, I solved this for VC. That's why I'm getting it.
Okay, no problem. So VC now it's clear, right?
No, sir, still
So you can calculate it like VC. You know the value of VIC. You can get the value of IE also. Okay, and because see IE, you can write it like IC plus IB. Okay, IB is what? IC is equals to beta times IB. So IB will be IC upon beta. If you know IC, right? So IC plus IC upon beta. So you can even include, it's like beta is how much? 100. Exclude this also, you will be getting almost similar value. So I guess you'll be getting IC, you know, IE, you know, to put the value of whole IVC, you'll be able to get it. Okay?
No, sir, still it is not coming in that range.
It's not coming in the range.
No.
Okay. Tell me the value. Minus 24 plus IC, just take it as 2, so 18, plus VCE times 2 times again 2 times IC is 2 times equals to 0. So this is minus 6 plus 4 plus VC. VC is somewhat nearby to 2. It's not the answer.
No,
It's not nearby 2.
no, it is 2.32 to 2.6 something range is given there.
Okay, so okay, calculated precisely. Then IC you were getting 2.03, right? Then minus 24 plus 9 times 18 and 9 times 20, so 18.27 plus VC plus 2 times 2.03. Okay, 2.03 plus 0.02. If you add it will be 0.25, something like that. Okay, so you are left with how much? 4.1 plus 18.27, that is 22.10, right? 37 minus 824. Oh, it is coming out to be lesser than that.
Yes, sir, that's the problem. I checked with accuracy also. I thought that process missing, but you know, the maximum and minimum both range I tried, and it's not coming in that range.
Yeah, it's I guess incorrect. Yeah, I'll have to check it. No, so if there, I guess this is wrong. If I see whatever you are saying is correct, around 2, I guess it will be 2. Let's, for example, it's even though I'm taking 2 also, I was getting how much? I was getting around 2, right? And thoda sa bhi increase. Agar if I'll increase the value of IC, it will be the value will reduce itself. The VC will reduce it. So I guess that will be more or less around 2 or maybe less than 2, not more than 2. I guess. Am I missing anything? I don't think so. I'm missing anything. This starting from 24 and drop from IC and then VC, IC. Yeah, it's correct. So I hope there's some error. Everybody got the same, right? I guess if we'll calculate it, it'll not be getting more than 2. I guess. Whatever the answer is
Right,
given,
sir.
I guess the answer is around 2.5. Okay, I'll correct it then. If this is wrong, I hope this is wrong only. If you have calculated the IC correctly.
And question number 5, is it that 0 points means it's not being accounted for, right? 0 points was given that question 5.
Okay, what is question 5? What is the problem in question 5?
The question is correct, but the points is 0 is accounted. Will it be considered or it will be?
Oh, 0 point. Oh, okay.
But question looks correct, but 0 points.
There is no error in the question, right?
Looks correct. The question looks correct.
Okay, that also I'll have to check with the team, right? What's the issue here? Why 0 point has been given? So if you got the score right, how much, like, if that was correct, how you got the score? You would have got the score, right? Week 7 is done, right? Already.
Right. Score is not reflected yet. Okay, there
Okay.
score. Okay, there is score.
Oh, okay.
I think I made mistake there. I'm not sure the right answer.
Okay, for the final 10th question, I'll also ask them to change the answers also.
Thank you.
Okay, so we'll meet again maybe in the Monday. We'll try to discuss some more problems from the PZT. I guess the clamper is also left up. But okay, this was a huge, like the chapter itself is like very huge. See, when I was reading this diode, this BJT,
It's
used to take
completely
a lot
new
of
event.
time. What?
It's completely new apart from the basic electrical thing. It's completely new.
Correct. Yeah. See, this is like this course itself is like the normal. Like when I studied as a network theory. Most of the portion of the network theory is there, and then analog we used to learn diode and the transistor, the basics of the transistor. I hope the basics of analog is also been discussed. I guess the MOSFET also has been discussed. That also mostly we learn in analog device. Like here, I guess an analog you'll be reading mostly about the op-amp and how to design a circuit with the help of the op-amp and how the op-amp will work as a differentiator, integrator, or many like I guess filters is not discussed here. So filters and all will be discussed in analog, I guess. Yeah, this is a course that is the most, I guess, tough for anyone. At least in the foundation, I don't see any courses that is tougher than this. So I'll have to put in more effort, at least for this. And if the circuit comes, like, it becomes a difficult course altogether. So when you'll be dealing with signals, that is very easy because that's like a maths. So that'll be very easy. Even maths 2 is not that difficult, easy in the diploma courses I'm talking about. Even BHD is not that difficult. So this is a tough course.
I think
Even
second,
analog is not
third,
that tough. Yeah.
the second quiz will be going to be most difficult as compared to the quiz one. Quiz one, still the circuit was there. Now I think completely new, a new concept.
Don't worry. Like next week we'll be solving a lot of problems, and that way all the questions mostly will be inspired from the quiz paper. So do not miss the session. When in the quiz, before the quiz one also, I try to solve almost similar type of a problem, but then also, okay, that's fine. Like in the circuit, you can do mistakes, but try to avoid it as less as possible. But we'll try to solve it. Mostly the questions will be inspired from the your paper itself. Okay, so try to attend the next week sessions. Yeah, Monday we'll be discussing the BJT, mostly the AC analysis, and the remaining portions of whatever week 7 or 8, week 8 mostly. Next week also we'll be having some like 1-2 extra sessions, and then I'll just try to solve it the problem itself. 3-4 hours it will take, like whole 1-2 sessions, and then I guess we'll be ready for the quiz paper itself. Okay, so let's meet it in next week. Okay, and
Sir, what's the problem with question 9?
question 9 VC is coming out to be around 2.
Question
But the
9, I
answer
think
given is
we are getting correct answer. Is within that range. But question 10, we found some issue.
yeah, question number VC I'm talking about. Yeah.
10, that is.
Okay, so I'll just drop it off. Enjoy the weekend, I guess, and then bye.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.
Thanks everyone.
Thank you, sir.
If you have any doubt, you just put it on the discourse or the group that we have created. Okay, so there also we can discuss if you have any doubts.
Yes, sir.
Okay.